Alright, now we're looking at cosine, horizontal and vertical shift. What's changed from sine? Absolutely nothing. So, amplitude, absolute value of A. Sorry, I got a little excited with the pen. Period. 2 pi over B. Intervals. Period. Over 4. Vertical shift. D. Horizontal shift. Set dx minus c equal to 0 and solve for x. Again, I briefly mentioned this on the last video. I want to emphasize it a little bit more here. So when I say set bx minus c equal to 0, more specifically what I mean is set whatever is in the parentheses equal to 0. So remember on the last video we looked at what happens when you factor b out of the parentheses? If you factor b out of the parentheses, or if b is already factored out of the parentheses, you don't need to multiply it back through to set it equal to 0. Just set whatever's in the parentheses equal to 0. So set bx minus c, or whatever is in the parentheses, equal to 0, and solve for x. This is now your starting x value. So, graph two periods of y equals negative 3 cosine x minus pi fourths. Our strategies are exactly the same for sine. That's why we're not going over them again. So let's find everything. Amp 3, absolute value of that number. Period. 2 pi over b. B is 1, so it's 2 pi. Intervals. Period. Over 4, which is pi halves. Vertical shift. There is nothing added or subtracted outside of the function. So that's 0. Horizontal shift. I'm going to set what's in the parentheses equal to 0 and solve for x. So my horizontal shift is pi fourths. Now, when I'm going to draw my axes, again, note your vertical shift and note your horizontal shift, because those are going to help you see if you need to emphasize above or below the x-axis, or to the left or the right of the y-axis. So here I can see that my x-axis is my vertical shift, because it's 0, and I'm just starting at pi fourths, which is just to the right of the y-axis. So I can draw like this. I have an amplitude of 3, so let's call this 0. Let's call this 3. Let's call this negative 3. Then we'll start at our horizontal shift. I have intervals of pi halves, so pi fourths. If I add pi halves, that'll be 3 pi fourths, and 5 pi fourths, and 7 pi fourths, and then 9 pi fourths. That's one period. Let's keep going though. 11 pi over 4, 13 pi over 4, 15 pi over 4, and 17 pi over 4. Now we want to plot points. So this was a negative cosine curve. What does that mean? That means that at our horizontal shift, we're going to start at the lowest point and then go up from there. And follow our pattern. That is one period. Continue on. And that's 2 periods. Draw in a lovely curve. I know you're thinking, wow, were you ever an art student also, Mr. Rumpf? No, surprisingly. But that's beautiful. That's 2 periods of our cosine curve. Okay, Now your turn. Find the amplitude, the period, the horizontal shift, the vertical shift, and the intervals. Pause the video, unpause when you're ready to check that, and then we'll get into the graphing. Okay, so we should have an amplitude of 3, a period of pi halves, our intervals are pi eighths, the vertical shift is -1, and the horizontal shift is pi fourths. One thing I want to point out, so you might have noticed in the past couple of days when we're doing this graphing trig functions, we're dealing with a lot of fractions. If you ever are struggling with division of fractions, make sure your answer makes sense. So a common mistake is when I see that the period is pi over 2, and then I divide that by 4, students sometimes make this 4 pi over 2, which would be 2 pi. Think about what the intervals represent. The intervals are cutting the period into fourths, or cutting it into 4 equal slices, you could say. Think about a pizza, right? So the intervals have to be smaller than the period. Otherwise it doesn't make sense. Alright, that was a side note. Okay, now that we have this, I want you to try and graph 2 periods. Pause the video, draw your graph, unpause when you're ready to check. Okay, so this is what our curve should look like. I drew in a new axis at -1 because that is what the curve is going to revolve or oscillate about, since it had a vertical shift of -1. I start at an x value of pi fourths because that was my horizontal shift, and then from there I increase by pi eighths. So I have to add pi eighths each time. Had an amplitude of 3, so from -1 I went up to +2 and down to -4. Because it was a positive cosine curve, I started at an x value of pi fourths and a y value of 2, and then I followed my pattern from there. The first 5 points is one period, the next is the second period. Okay, so what did we learn? We learned that cosine is the same as sine, essentially. What do I mean by when I keep saying that? Well, let's look back at this real quick. Sorry, I know, you're like, can we just end this video? But think about if I draw a line right here, and I draw a line right there. That is a sine curve, right? Okay, so that's what we can see, is that cosine and sine, when we're graphing them, they are the exact same curve, but just shifted over from each other. That goes to your co-function identities. Remember that cosine of pi halves minus theta is sine of theta. That's a horizontal shift. Okay. Anyway, amplitude, absolute value of A, period 2 pi over B, intervals period over 4, vertical shift is D, horizontal shift, set what is in the parentheses equal to 0, solve for x, that's your new starting x value. Graphing strategies are the exact same as the sine. Use your vertical shift and your horizontal shift to help you start the scale of the graph, and then just go increase by the intervals.